Hello, my name is Quentin.
And I'm Valo, behind the camera. Hi.
Today, we're going to be taking you on a tour of the solar system. Now, before we start, I would like to ask everyone to open the Google form in the description and just fill out the first page. It's really easy, and it would mean a lot to us if you did it. It'll only take a couple minutes. So if you could do that, take a little bit of time out of your day, we'd really appreciate it. So right now, I'm standing in front of the Thomas Jefferson High School dome. Right, as you can see, it's pretty big. And the purpose of our project is we're trying to get the dome to be the sun, right? So in the scale of the model, the dome, we shrunk the sun down to the size of the dome, and we scattered the rest of the planets in the solar system around Annandale. And we're going to show you guys those planets today. All the planets are shrunk down according to a couple equations we figured out. So if you follow us to Mercury, we'll explain along the way.
We wanted to make the dome's 20 feet equal to the sun's 4.6 billion feet. Then, we looked up how far away the planets were from the sun. It varies a little bit, but let's say Earth is 489 billion feet away from the sun. We can use fractions to figure out how far away we need to go. By using the scale over the real-life distances, we get this equation. By multiplying both sides by 489 billion, we found out exactly how far away we needed to go for the actual models.
Alright, so we've just arrived at Mercury, which is the closest planet to the sun and is also the smallest planet in the solar system. Now, because it's so small and so close to the sun, it spins really slowly because the sun is pulling really hard on it. So that means that one day on Mercury is actually 59 days on Earth. Now, at this point, the distances between the planets are getting so large that we actually have to go to the spaceship in order to get to the next planet. So if you follow me, we'll get right there.
So, even though Mercury is so small, it's also very dense. Unlike Earth, which is hot on the inside, Mercury is completely cool past the surface. Beneath its rocky shell, Mercury is basically a solid metal sphere. Additionally, Mercury's atmosphere is very thin, so while we have all sorts of interesting weather here on Earth, there is almost no weather on Mercury. Since Mercury is so close to the sun, it gets really hot in the daytime. The side that faces the sun can reach upwards of 800 degrees Fahrenheit. On the other hand, the side that faces away from the sun is super cold. It can reach as low as minus 300 degrees Fahrenheit. We're lucky that we have an atmosphere on Earth to protect us from the extreme heat and cold of outer space.
Alright, so we've just arrived at Venus, which is the second planet from the sun, and as you'll notice, it's a lot larger than Mercury. In fact, even though they're close, Venus and Mercury are not similar at all. Venus is very similar in size to Earth, and in fact, excluding Earth, it is the largest planet and the inner planets. Now, we're going to learn some new fun facts about Venus on the way to Earth.
Another fun fact about Venus is that astronomers consider it to be Earth's sister planet. Venus and Earth are similar in size and are made of similar types of rocks and metals. Venus and Earth are the only rocky planets with atmospheres, and also the only rocky planets with magnetic fields, which shield us from harmful solar rays. Despite this, the two planets are also very different. The atmosphere on Venus is almost 100 times as thick as the one on Earth. This causes immense pressure to build up on the surface, which releases heat, causing the temperature difference.
Alright, we just arrived at Earth. Now, as you can see, Earth is actually tilted, which all of the other planets aren't. This is why we have seasons, because when the sun is here, the lower hemisphere is hotter. And then when it's over here, the upper hemisphere is hotter, right? Now, Earth is the largest planet, and it's also the heaviest. That means that when you're standing on the surface of Earth, you're going to weigh more than you'll weigh on Mercury, Venus, or Mars. And finally, we're going to go to our last planet, Mars, off this way, and we'll head back to the spaceship now.
Earth is the only planet that sees plate tectonics, the process that makes our continents. Earth's outer shell, the crust, is made of about 20 large masses of rock called plates that are constantly moving very slowly. This is why we have earthquakes. When two rocks slide past each other, the ground shakes along the area of motion.
Alright, So we've arrived at our last inner planet. This is Mars, and it's really red, as you'll notice, because there's a lot of iron on the surface. Now, when iron mixes with water, it starts to rust. And that's important because water is a big component for life. We know now that there's ice on Mars, which means that billions of years ago, if the conditions were a little better, there could have been liquid water on Mars, and there could have been life on Mars. And so scientists are really, really interested in the possibility of life on other planets. Now, this concludes our planet walk. I hope you really enjoyed it. If you enjoyed the video, please leave a like. We'd appreciate it a lot. And make sure you fill out the last part of the Google form that you sent earlier. Thanks for watching, and we'll see you later.